Okay, I'm gonna do several of them, not all, several of them worksheet of the redox balancing reaction with through F reactions, and I chose several of them, which is important for you to understand. The rest of them you're gonna find it on there. I posted on Angel and the answers, so you can always do it and check your answers with the answer sheet. Let's start with 2C. As I said, I chose them, several of them, because I wanted to explain things that are important and basically the most difficult one. That's the one I chose, the one I think you would have problem with. So here we got, right, MnO4. Let's start with the oxidation states first, oxidation numbers. So if we have here plus 7, it's plus 7, but let me write it down. We got x here that you don't know, right? It's x plus minus 2 multiplied by 4 equals minus 1 is the total charge. Remember the subscript, oxidation state plus the subscript multiplied by the oxidation state of the second equals the total charge. So it would be 8, yeah, minus 8 equals to minus 1. So x would be plus 7. The next one. The next one would be, okay, the next one would be, so here, manganese is 7 plus 7. Okay, plus 7. Now let's look at this. The oxygen, remember rule number 3. Oxygen will always have an oxidation number, majority of the time, of minus 2. And except of course the uncombined oxygen and peroxide, which is minus 1. So here oxygen is minus 1 and hydrogen with non-metals have a charge of plus 1 always. Manganese plus 2, yeah, and here we know it's oxygen. So the ones that are changing is manganese from plus 7. I write it like that as a guy. I said you don't have to do it, and it's not required. In fact, I do it like that because, and then oxygen, let's take the subscript, remember, has a subscript of 2 on both, and it goes from minus 1 to 020. So let's look at each one and see. The coefficients and the mass is already balanced. Manganese, 1 and 1, and oxygen, 2 and 2. And let's go with manganese, right? And its oxidation number is going down, so it's gaining electrons. Electrons going up, gaining electron. Manganese is reduced and is the oxidizing agent. Oxidizing agent. Now, the oxygen oxidation number goes up, electrons go down, so it's gonna be goes up, electrons go down, so it's losing electrons and it's being Leo oxidized, and it's the reducing agent. So here we go, and we have, let's write the electrons on the half reaction and balance them. So we got manganese is going from plus 7 to plus 5. So it's gaining 5 electron. Now oxygen from minus 1 to plus um, to 0. So it's gaining 1, but you have 2 electrons. So it's 1 electron, 2 atoms. Multiplied by the 2 atoms, the 2 oxygen, it gives me a total of 2 electrons. So where do we put it? If it's gaining electron for the manganese, it goes on the left. So here we go, 5 electrons. And here the oxygen would be plus 2 electrons. So that would be, we have to multiply and balance the electron now. So we got 5 on top and 2. What do we need to do? To multiply this whole equation by 2 and this one by 5. Common these multiple. So it's going to be 10 electrons plus 2 manganese. I don't need to write now the charges. Well, manganese plus 2, yes, because it's on the on the um, on the equation. So it's gonna be 2Mn2 because it's the charge. Now on the other side we got 5O2, right? Gives me 5O2. Remember we're multiplying by 5 both plus 10 electrons. So this is gonna be electrons and electron cancels out, and it's gonna be 2Mn plus 5O2 gives me 5O2 plus 2Mn plus 2, or 2 plus. So if we rewrite the equation on the right, we take the coefficients that were here. So we put in front of the MnO4, we had to put a 2 here. MnO4 minus, we have to put a 2 plus 5 in front of the hydrogen peroxide. It gives me 2Mn plus 2 plus 5O2 gas. And by the way, this is aqueous. Yeah, don't forget to put it. I maybe jump that and do it faster so I don't need to write the aqueous and aqueous, but don't forget to put it. Okay? And this is gas. And this is gonna be in acidic medium. Now, if we look at this, let's balance the charges now. Balancing the charges, we got here, okay, charges. We got on the left side, we got, remember we multiply the coefficient by the total charge of the molecule is minus 2. And on the right side, we got plus 4. If it's an acidic medium, how much do we have to add? And it would be on the left to get to plus 4. It would be 6 hydrogen plus, because then we have 6 minus 2 plus 4, and on the right side we'll have plus 4. So we put here 6H plus, and then if you look at that, we need to balance the hydrogen. We don't have hydrogen. With what? With water. H2O. How many? 3 of them. So with 6 hydrogen, 6 hydrogen, well, manganese should be balanced and oxygen. What's going to happen with the oxygen? We have 2, this is a 2, 8 plus 10, 18, 10 plus 3, 13. Let me see the results. I'd say I know what sorry. I know that's why I like to do it before, because if I am making a mistake like this, you probably catch it. I can catch up any. I did it already, all this. So how much? We add 6 hydrogen, we balance the charge. Now H plus. But now look at this. And how many hydrogen? That's, I forgot to count the 2 here. 6 plus 10 is 16. So we need 16. What do we need to multiply that? Now we balance it with water, of course. And we need to multiply by 8. So 8, 16. On this side we have 6 plus 10, 16. Now let's go with the oxygen. And oxygen would be 8 plus 10, 18. 10 plus 8, 18. And it's balanced. I did it right the first time, but when I'm recording, I maybe forgot to do something, or as I do it as I go, as I'm recording and I'm solving it myself. So let's go with the next one. And this is 2A. 2A, why did I choose this one? Because if you look at it, right, you have oxygen from 0, okay, to this oxygen would be -2. And nitrogen, here the oxygen is -2. So one oxygen here is the same. It's -2, -2. But this one, that it's a gas, is going to be changing to -2. With the nitrogen, we got X -2 equals 0. So the oxidation state of nitrogen is +2. And the nitrogen here would be X plus -2 multiplied by 3 equals -1, which is the total charge of the NO3 minus of the nitrate. So it's going to be -6 equals to -1, X equals to +5. So now let's write our half reaction. Remember, we start writing any element you want to choose. We start writing. Okay, we start writing the one element, and don't forget the subscript O2, and here would be O3. Why do we put that one? Because that's the one that is changing. Now on here, right, N changing from +2 to N +5. We need to balance then the half reaction, the atoms. Now let's start with the oxidation reduction, which is going to be O, let's start with O. O2 is changing from an oxidation state from 0 to -2. So oxidation number is, and so electrons are gained. So its Gr would be, oxygen would be reduced, and it's gonna be oxidizing agent. Now look at this, and we have, let's do the electrons also. For the oxygen, how many atoms do we have? 6. 2 by 3, 6. And the change in electron would be from 0, it's gonna gain 2 minus 2. It's gonna gain 2 electrons. But we need to multiply by the total, because it's going to be the oxidation number of one oxygen. If you have a total of 6, would be giving 12 electrons. So a total of 6 uh, atoms would be 12 electrons. Now, if it's gaining the 12, you put it over here. 12 electron every time it's gaining. Now, let's go with the nitrogen. Nitrogen goes from oxygen 0 here to -2, and nitrogen would go from +2, if you can see it here, +2 to nitrogen +5. So oxidation number is going up, the opposite of oxygen. Electrons are going down. Leo, because it's losing electron, right? And it would be oxidized. The nitrogen is being oxidized by the oxygen. By the way, if you don't know, that's why it's called oxidation, because that's what oxygen does to many metals and non-metals. And it's gonna be two metals basically, and it's gonna be oxidized, and it's the reducing agent. Okay, reducing agent. That's an R. So how many nitrogens you have? One. So we don't need to multiply. Number of electron would be from +2 to +5 is losing 3 electron. And we have 1 nitrogen. So it's going to be 3 total electron. And as it is losing it, we put it on the right. 3 electrons. Now, 3 to 12, you need to multiply this whole equation by 4, this half reaction. So it's going to be, let's rewrite everything, 12 electron plus 302. The first half reaction stays the same. Uh, Gives me 203. Okay, now not necessary to, you don't need to write the charge now or the oxidation state unless it's a charge, like the case of manganese, that it was a charge. 4n, right, is gonna give you 4n, now 3 by 4, 12 electron. The purpose of this is to balance the electron. You balance the electron like you're balancing any charge. Okay, so 4 nitrogen plus 302 gives me 4 nitrogen plus 203. Now let's take those coefficients. This is the net redox. And let's take those coefficients up. As you cannot see everything, just remember, well, let's do something. Let me copy and paste it up here. Oh. Okay, I'm gonna do it on top here. Oops. Okay, here we are. So we got here, okay? Let's balance it here. We got 3 in front of the oxygen, 4. I'm gonna have to copy it again. So it's gonna be 302, right? gas plus 4 for the O gas gives me NO3 aqueous. So you got here 4 nitrogens and 2 oxygens. So you put the 4 in front of the nitrogen. 6 plus 4, 10, 12, and then we'll balance the oxygens. Okay, so we got here 3O2. I'm trying to find out where the pen is. Where is it? I'm gonna have to put a pause. I think I lost the pen. Ah, here it is. Um, so it's gonna be 3O2 plus 4NO, 4NO, NO3 minus, and here no charge. So let's go ahead and balance the charges here. Charges. Let me do something better. Let me copy it at the end. Put it down. This is the equation with the already balanced the half reaction, the nitrogen, but we can balance the oxygen. So this is an acidic medium. So we got -4. What do we need to add here? Charges. Charges. Here it's 0, and on the right would be -4. What do we need to add if it's acidic, we need to add, remember we had H plus. 4H plus on the right, so -4 plus 4 equals 0. Plus 4H plus. So it's gonna be, now on the left side, we know already that we have to add water. So how much water we have to add? We have 4 hydrogen. We're gonna add 2H2O. So if we got 2H2O, 2H, 4H, 2 by 2, 4. Now let's see, the oxygen should be balanced. We got on the oxygens, right? We got on the left, we got 2, 2 plus 3 by 2, 6, plus 4 equals 12. And on this side, we got 4 by 3, 12. Here we got everything balanced. And this is, oops, sorry. This is the equation. Okay. Okay, let's do the next one. Oof, that's a lot. 4A. And 4A, a little bit smaller. Okay, 4A, we're going to do the boron, which is a nonmetal, right? And let's do this one and I'll start posting the video. The boron, I have the impression that the pen is running out of battery because it's kind of like, let's see, I think, okay, here it is. Boron. What would be the boron? It's non-metal, so the hydrogen would be +1, and we multiply by the subscript and equals to -1. So x plus 4 equals to -1. X is -5 because it's -1. Chlorine here. Chlorine would be um, Cl. It would be X again. So it would be X plus -2 by 3 equals -1. X would -6 equals -1. So X plus 5. So that's the chlorine. Here, hydrogen again is +1 multiplied by 2 plus X is the boron plus -2, the oxygen multiplied by 3 equals to -1. And it's 2 plus X minus 6 equals to -1. X minus 4 equals to -1. X 4 minus 1 plus 3. So boron is going from +5, right, to -5, from -5, -5 on the right, boron plus 3. And hydrogen would be, chlorine is the other one that is changing and it's going from +5 to -1. Let's make sure, yeah, the no coefficient, so and also the masses are balanced. Let's go ahead and write our little thing, and it's boron. Boron goes, oxidation number is going what? Up. Electrons are going down, losing electrons, oxidize, and it's the reducing agent. Now let's go with, let's write down the electrons too. It's only one atom and it's from -5 to +3. So it would be -5 plus 3. If we add 8 electrons, it's 8 electron to go to +3. -5 to 0 is 5 here. -5 to 0 is 5 electron losing. Plus, we go from 0 to +3. So it's losing 8 electrons. And how many atoms we have? 1 by 1 bar. Now let's go with the chlorine. Chlorine, its oxidation number is going down, is the opposite then, electrons going back. So it's gaining electrons and it's reduced and it would be the oxidizing agent. So it would be how many electrons from +5 to -6, the same thing. If you're going from +5 to -1, sorry, +5 to 0, 0 to -1. So it's going to be 6 electrons. How many atoms do we have? How many chlorine? 1. So it's by 1. So we put our 8 electrons. If it's losing electron, we put our 8 electrons here. If it's gaining electron, as the chlorine is, we put our 6 electron here. 6 electron. So now we have to balance the electron. What do we need to do to balance the electron here? Is, let me see where it is. 40, let me make sure. It should be this by 6 and this. No, If we multiply 8 by 3 is 24. If we multiply 4 by 6 is, let me make sure everything is right. Yeah, yes. 3 here, right? You start looking for the minimum common multiplier. So here would be 6 by 4. So we multiply the first by 3 and the second one by 4. So it would be 3 boron gives me 3 boron plus 3 plus 3 by 8, 24 electrons. So 24 electrons plus 4, 24 electrons plus, this means an electron with a negative, plus 4 chlorine gives me 4 chlorine. So if we cancel out the electron, because that's what we're trying to do to balance the electrons, it's going to give me 3 boron plus 4 Cl gives me, and I forgot, no, yeah, 4 Cl. So it's going to be 3 boron plus 4 Cl. So let's take those 3 and 4, net redox is this one. Let's take that 3 and 4 up to initial equation. So we got the boron was 3, right? The boron 3 and the chlorine 4. So we put a 3 here, a 3 in front of the boron, a 4 as coefficient of chlorine. Now it's basic. Let's go ahead and balance the charges. Let me do it down here. So we have space. So let's, I know I didn't copy the other one, but we can do it directly. I should have done this before. They're losing batteries. Definitely. Hmm. Ooh, I'm gonna have to put a pause to see if this works. Okay, I think I got it now. Okay, yes, 3 boron plus 4 Cl plus 3 boron plus 4 Cl. Okay, now we got the 4 Cl. Now let's go ahead and balance the charges. Okay, on the left side we got minus 3. Remember, I'm multiplying the coefficient by the charge. Minus 4 is minus 7. On the right side we got minus 3, minus 4, minus 7. So it's balanced. It's balance, balance, balance. Now, what do we have to balance now? We have 6 hydrogen and we got 12 hydrogen. We just add water on this one. Let me just make sure I didn't make a mistake before because I don't wanna. Mhm. Yep, you don't need to balance charge. So we got here, right? Here, as this is a basic, we got what you need to do OH. If you add OH, it's basic. You're gonna mess it up. It's already, the charges are already balanced. So the only thing we need to balance is first start with the hydrogen. We got 12 hydrogen here and we got 6. So if we add 3H2O, which is 6 hydrogen, only water with no charge, and 6 by 6 plus 6, 12. 12 here. Now let's see if the oxygens are balanced. 4 by 3, 12. 3 by 3, 9. Plus 3, 12. And this is the final equation. I'm gonna stop the video here and start with another one, okay? In a little bit. So I'm gonna start posting this one.